Okay. So, uh, hello. This is Tomoko Yonezawa in Kansai University, and very thanks to giving me such opportunity to talk you about my past work. So, today I will introduce some of past work related to fluid interaction with musical toys. Additionally, not only the past work, I would like to introduce some of my work ongoing. So, as my self-introduction, I'd like to show you some movie of current work. I was from ATR, Advanced Telecommunication Research Institute International, and I will give a talk about musical instrument using water in 1999. It's very old, but my current researches are widely treating 3D sound, virtual reality, and educational agent for application, emotional robot with physical touch in the field of human-agent interaction and musical emotion. And I have a practical course in digital music generation using pure data. So here I'd like to show you my current work about artificial emotional touch of a robot. Sorry. And so we examine various touches of changing strokes, uh, stroke length, and cycle duration to vary the emotional expression and found some representative touches to express like this. And today I will talk you about tangible sound and musical instrument using flowing water string that is a center region of the Steve's taxonomy. The another topic to talk is interaction with fluid body and mind, including statutory musical instruments and water body expression for artificial presence that are not appeared in the proceedings. I'm sorry. So, tangible sound was presented in ICMC International Computer Music Conference about 20 years ago, but the picture was taken in um, ATL Open House in 1999. Here is a demo movie.
Tangible sound is a musical instrument with a novel user interface using fluid water. As fluid and sound have common characteristics, fluid water provides us with a performance interface suitable for flowing sound and music. For example, both change shape over time, and neither can be grasped. Water is an essential material in daily life, so an instrument using water can be more friendly and even become an amenity in future life. Although there are many installations and interactive arts using water, virtual water's use and practical uses of fluid meaningful musical instruments. For measuring the upper flow, we use the radius of the flow under the faucet by sensing the electrical resistance of water with nichrome wire. The lower flow is also measured by resistance of the lower water. Funnels are prepared as drains, and in each drain we put nichrome wires for sensing water level, which is used to measure the amount of lower flow. The level is raised when the amount exceeds the draining capacity of the funnel.
So, um, tangible sound was a musical instrument uh, aiming a novel experience with the sense of touch on water that changes uh, its shape over time. And also the music and the sound also change its shape, not shape, but change over time. So musical output are designed to uh, linked to the water state that is changed by the interaction with the user. So then, mainly, Shishiodoshi and Suikinkutsu, a natural garden instrument in Japan, inspired me to design the tangible sound. Shishiodoshi store water in bamboo joints, and the bamboo rotates so that the water is automatically discharged when it exceeds a certain weight, and when it returned after that, the bamboo could hit the bottom part and make a beautiful sound like this. And suikinkutsu is like an earthenware pot that makes a beautiful resonant sound of the water drop pouring down from the top. The sound is somehow metallic and mystical. Both objects are beautiful objects that decorate Japanese gardens with soundscapes. An important characteristic of sound and music is just change over time. Like other fluid, water has some same characteristic. Furthermore, the tactile perception of water is similar, but they have uncontrollable factors and bring natural and attractive feeling. Link between them also provides a strong impression and intuitive feeling of that natural feeling, including human control, have some uncertain factor anyway. So here is the detail of the system. Water flow from upper tank to the lower tank is controlled by the faucet. So the amount of the water flow changes the diameter of the water stream, and to sense the user's input on the water, uh, we use several sensors with two nichrome wires. So, such as the water diameter can be sensed by two nichrome wires set like this, and drains. The, the depth of the water is detected by two nichrome wire in parallel. So not only placing the sensors, we should detect the user's input on the water flow, So, such as scattered water drops are sensed in sub-drains because we have multiple drains, not only main drain. So it, it can be detected even it's a small drops of the water, and stopping action of the user is detected by the difference of the upper flow and lower flow. So um, for people in experienced in musical theory, it's not very easy to understand the dynamic flow of the music. Also, now analyzing music by focusing only our auditory attention is difficult because the flow constantly changes cannot be controlled. So we focus on the easy control, but not perfect control of the music flow using the water. No need to practice, just to play, and no need to learn music theory. So next, I'd like to move on to sweet body and mind that include my current work, that's past work, which is described by Kenji Matsuya. First, I'd like to talk about the living being and body. So we have 70% or 60% of water in our body, and including blood, sweat, other things. And our body can cannot be controlled if we have instinctive and strong emotions. So there are very strong body emotion connection. And also the water and fluid in our body are if affected by such emotion. This is my student work using the sensor of heartbeat at the fingertip of the user. And here is a blood tank, blood tank to provide some water blood flow at the motion of the heartbeat, which is controlled by water tank and servo motors. And another one, can you see here? The robot hands can have some sweat to express fear or strong uh, mm, emotion. And not only sweat, we use goosebumps to express its own instinctive emotion. And the robot hand moves flexibly, but it have not so soft body, but it have water. Have, okay, next I'd like to introduce you the breathing robot with lung. To be like living being, it makes some airflow, not water flow, but uh, the user can feel some activity of the body, even its very artificial presence. And also, uh, the stuffed toy is very flexible, and we can imagine if it have some uh, very soft meat flesh. So we adapted such robot. So um, our focus about the soft body and flexibility with music is based on the interest to living being, and also the flexible body have also controllable and uncontrollable presences factors. So the user can feel some softness, and user can listen to the musical sound connected to emotion of the presence. The presence means the artificial being. This is also not not presented in the proceedings. Okay, okay, sure. So there are some of stuffed toys work, but I'd like to conclude that the animals and humans have water in our body, not only interacting with water on the outside. Water is the most special fluid to make humans to give uncertain feeling of the outside world and the own body. The tactile music interaction using water toys is are expected to generate our fundamental and primitive bodily sense and emotion simultaneously. The fusion with the sound and fluid water also expected to create novel experience for the user. Such experiment might generate strong emotion, we believe. Thank you very much. Sorry, thank you very much.
So this is a good example in terms of interface technology, where you've got the water engages with the technology, and the human engages with the water as well. So it kind of puts the water at the center in terms of interface taxonomy. So very, very interesting. Um, Next, we've got Florian up to present on some water, kind of getting to understand the water, towards beginning to understand WaterHCI. And yeah, let's take it away, Florian.
So again, my name is Floyd Müller from the Exertion Games Lab at Monash University in Melbourne, Australia. I'm talking about towards beginning to understand water HCI. A lot of people contributed to the work, so I thank all of them for their contributions. And I'm going to talk about mostly from a previous work that we've published under the title of 6 Degrees of Water Contact. There's a bit more in there, but most of the work, yes, as I said, is from our wonderful collaborators that I acknowledge here, please. I'll start with talking about, of course, why we are interested in water HCI, in particular playful water HCI, because we're very interested in playing with water. I'm going to talk about 6 degrees of water contact. So these are our this is our main contribution, and that allows us to identify 27 design features. I don't have time to go into all of them, so I'm just going to highlight a few of them, and they're important because they allow us to see an effect of a degree of the water contact on the design features. And then I conclude with some, I think, exciting opportunities for future work. So why are we interested in water? Because water invokes a lot of emotions in us. It can be fear, but also be excitement, serenity, and so forth. You all know about that. And water has been included in play throughout history, Here's a picture of a castle in Austria. I've been there myself and tried this out. So the idea was that the owner of the castle invited his guests to his estate and said, let's have a picnic out in his garden. And then they were seated on this table for the picnic, and he had a lever on the side that he could trigger, and then water would jet up from the seats. And of course, you know, like they would all jump up and laughter abound. However, when we look at digital water play, we find it's rather underexplored. This is a picture of what Red Bull did recently. They used brain-computer interfaces and eye tracking to figure out where surfers are looking at when they are surfing. And you can see that thanks to technological advances, we've now been able to do BCI eye tracking in water, not just waterproofing it, but also make it robust enough to physical water play. However, that study wasn't really an empirical study. It was more like a PR exercise. So we don't really have too much information about that. But we acknowledge that we can do digital water play is more approachable due to the advances in digital sensing technology. And we want to leverage that fact. So here the target audience are designers, researchers, practitioners, artists, both from academia and industry. And for that, we identified that we can categorize the amount of water contact when it comes to technology and categorize them in 6 different aspects or perspectives. I'm going to give you a brief overview of all 6, and then I go into detail after that. So this is about vicinity, because we argue that even if you're just sitting next to a pool or on the beach, just the reflection of the sun on the water, the temperature coming from the water already affects your experience. Sporadic contact is about rain and getting rained on or getting sporadically in contact with water. On top of water is about the aforementioned surfing or kayaking, paddling, and so forth. Partially submerged is the kind of water play that you often have or when children get in contact with water first when they play on the beach. Floating mostly refers to swimming, and underwater to diving. And there's HCI work that covers all these different degrees of water contact. For example, give you an example for each. The Steve Benford's lab in the UK did mixed reality performances, what they call, where they had a curtain of water coming down and then they projected onto that. That's for us an example of engaging with water from a vicinity perspective. Sporadic contact is an example. Here's Waterball Z or Waterball Z. It's an augmented fighting game using water as tactile feedback. On top of water, examples for that are coming out of the Swim Games project in the Netherlands, where they designed with children and teenagers games in which swimmers often jump in the water, and that is detected by a Kinect, because obviously the Kinect works better above water than underwater. So this is the top of water perspective, that our degree of water contact that I highlighted earlier. When it comes to partially submerged, we can point to some of our own work, thanks to Sarah Jane Pell, who developed these autonomous robots that are in water, and you interact with them by partially submerging your hand in order to play with these little robots. Floating refers mostly to water, as I said. An example of an HCI project that engaged with that is Moby Dick. It's an interactive multi-swimmer exertion game in which software detects the stroke that you are performing and then connects you with other swimmers in order to allow you to play a digital game together. Underwater is an example where people use augmented reality, but put people in the pool so they can actually swim in a real physical pool, but experience virtual fish and coral reef. And now that we have these 6 different degrees of how we can engage with water, we argue it might be useful to now look at the following 4 things and how they are affected by water when you bring the player or user and the computer in contact with water. So these are the state that the player or the computer is in, sensing, acting, and networking. What does that mean? Well, we argue you should look at both from a player perspective, what water affects the player across state, sensing, acting, and networking, but also in terms of the computer, how water affects its state, sensing, acting, and networking. And when we do that, we end up with all these different constellations that I mentioned earlier. I don't, as I said, have time to go all of them, so I'm just going to highlight a few of them. So for example, if we look at the player and the contact with water, their state changes, right? So obviously, for example, if we look at breath, you have to come up and get some breath. So we need to consider that when we design. Similarly, we can look at the computer and the state of the computer. When the computer comes in contact with water, the state is particularly important. For example, battery life changes when a computer becomes in contact with water. Electrical insulation is another example, right? We need to electrically insulate the computer in order to make it work when in contact with water. Sensing, similarly, right? So we can talk about how, or we can consider how water affects the hearing of a player. But we also need to consider how the computer sensing is affected, for example, through vision sensors. We can't really use the same vision sensors that we use above water, or if we do, we need to consider different lenses and so forth. Same applies to acting, so that's the third aspect here. Our dexterity changes, our exertion changes when in contact with water. For example, we can't run as fast underwater than above water. And similarly, we have to consider how the computer changes, how we think about audio. For example, we can't really use the same speaker underwater, or at least the speakers still work underwater, but obviously some frequencies work better than others, the distance is different, and so forth. Last thing is networking, right? So this is how people communicate with one another. So our communication obviously changes underwater. We can't speak, for example, when we're diving. And our human proxemics changes, which is the distance that we have with other people. Our distance changes when we're in water with other people. For example, we always stay so far apart that we can do a stroke kind of actions to stay afloat. And similarly, if we look at the computer and the effect water has on the computer when it comes to networking, we can see that our wired connections changes as well as our wireless proxemics, right? So wireless networks, if you put a Wi-Fi network underwater, then it still works, but not to the same extent that it does in air. So these different states allow us now to look at from the player and computer, look at the player and the computer perspective when coming in contact with water. And that allows us to create this table. So what I just showed you now is these, you put these on the y-axis, and what I talked about earlier, the different ways of how you get in contact, we can put it on the x-axis. That creates us this nice multi-dimensional table with all these different cells in it. And the extent of the water effect, we can now color in these different shades of blue, because we can see that when it comes to underwater, the player design features are affected to a higher extent than, for example, when you only consider the vicinity of the water. Again, I don't go into detail of all these cells here, but I just want to highlight that this kind of thinking helps us now to determine where are the challenges and where are the opportunities. And we can do that not only for the player perspective, right? How is the player affected by water, but also how the computer is affected by water, right? Obviously, when we look at the computer and the challenges when it comes to the technology, we can also highlight that with different colors of blue, high extent, low extent of the water effect. And just to sum up, I want to highlight that these different shades of blue allow us to see these challenges, but rather to see them as constraints. I want to highlight that we can also see them as opportunities. And I think a really nice example for that is Jelly Stomp, a game that actually uses these constraints but turn them into playful opportunities. The game works in the following way. It uses Sony PlayStation Move controllers that wirelessly via Bluetooth connect to the actual PlayStation. And the game designers, they programmed the Move controllers in a way that if the connection is alive, then the controller lights up. If the connection breaks, the light goes out. And your goal is to keep the light on. The game designers nicely waterproofed the controllers by putting them in condoms. So they made them waterproof, and then they attached them to the player's legs. And it's played in shallow water, like in these puddles or on the beach or in shallow rivers. And the goal is to constantly keep up the light, i.e. keep the Bluetooth connection alive. So what you have to do is you basically have to lift up your legs constantly and jump around in order to keep the Bluetooth connection alive, i.e. don't get the PlayStation controller underwater because it breaks the connection, therefore the light goes off. So it creates this interactive water dance as a result of seeing the constraint of limited wireless connectivity when it comes to water, turning that into an opportunity. So in conclusion, I present a lot of opportunities when it comes to digital water play for knowledge growth and innovation. We highlighted that there's a different effect of the water across different degrees of water contact. And we encourage you to see constraints of the water environment as opportunities. I want to highlight that our taxonomy of the 6 degrees of water contact is just the first step, and we really want to encourage you to design for these different cells that are highlighted, so we can begin to really grow the field of water HCI. And with that, I conclude my talk. I show you again the 6 degrees of water contact that are part of the talk of towards the beginning to understand water HCI. Again, I acknowledge all the people who were involved in that work. Again, my name is Floyd Müller from the Exertion Games Lab. Thank you very much.
Oh, okay. Excellent. Yeah, that was a very good talk. And I mean, one thing that's interesting too is the ordinality here. I was just saying, like, vicinity on the left on the slide, and then you've got sporadic contact. Like, if I look from, say, my own experience, like this morning I had a shower, which is sporadic contact, and then let's say you take a ferry. There's a ferry that takes people across to the island. To me, I would say a shower is more water. I feel wetter in the shower than I do when I take a ride on a ferry to the island. So I'm not sure the ordinality, like I like this taxonomy, but I'm not sure it makes sense to think of it as a taxonomy. I'd think of it more as an analog, like a continuum. You could say, well, how wet do I get? That's one dimension I could put. Or because the ordering could be permuted, and so we might not even agree whether a shower is less contact with water than a boat ride, but I still think it's interesting. And then I guess the other thing that we talked about too is whether the water goes in you or you go in it. So there's this idea of submersion, but then there's the other side when you put water in yourself. So you can either put yourself in the water or put the water in yourself. And so I think it would be fun to kind of play out some of these things. Like we could almost consider some sort of analog or continuous or undigital taxonomies that say the degree of wetness that you experience, which could be a continuous floating point number, how wet you're going to get on this ride, for example, versus other things like that. I think those would be fun little ways to carve up the space.
Yes, yeah, absolutely, totally agree. To your question about like water inside you, like when you drink water, we're doing a lot of work also on human food interactions, and that is not captured by the taxonomy, right? And we acknowledge that, and that's a limitation that where we really went like, okay, we only look at that things where you go into water rather than water into you. So yes, yeah, that's certainly a limitation for that. The dimension, yes, yeah, we really see that as a dimension and just use these categories to roughly identify key steps along the dimension. So we do see that rather as a dimension where you, like, as you described, it's more like a slider where you move along, because obviously example with a shower, right? So if I have a really high pressure shower, it's different than if I just have a few drops coming out of a broken shower. So we see that as a dimension where you move along or can move along. The designer can move the experience for users along. But I think it's still helpful to have these broad categories along it, because I would say that having a shower is, significantly different than actually diving into water. So that's where it kind of comes from, our approach of using categories along a dimension. But yeah, I totally agree that.
Yeah, that was. Is Atlas here? Is Atlas ready to speak at 6?
Just went down for a sec. Yep, he is.
Okay.
Okay, keep going.
Oh yeah, so yeah, that's good. It's quite nice to see, we could build that out. We could sort of build on some of these ideas and create. One of the things I often think about is imperatives. Like when you go down to Ontario Place, they used to have no swimming signs there. And then there was a film production company came and wanted to do some filming on the beach, so they took the no swimming signs down. And fortunately, they left them down. There are so many of us swimming. By then, we had about 200 of us on many days. We'd have 200 people on the beach swimming during a no swimming day, like when there's no swimming sign, and the security guards would come and tell us to get out of the water, and people would just stand their ground and stay in the water and say, okay, well, we're in federal land because it's a province up to the beach. When you cross the watermark, you're into national waters, federal land. And so in some sense, if they tell you not to swim, it's like unlawful confinement or where they're false imprisonment, where they're trying to keep you in the province and prevent you from going into the country, across the provincial border. And so we kind of got into all these discussions, but a lot of these imperatives come down to like no swimming, no fishing, no drinking of the water. And when I think of hard imperatives, I think of hard-edged taxonomies like the law and police and everything, like taxonomies that have very crisp, well-defined edges. But then there's taxonomies that have softer edges that are more human rather than legal. And so it's kind of interesting to look at some of these differences there and how we can carve up the space. And I'm sure in the days that come, we're going to keep the site alive and continue to take input and continue to create interaction and dialogue. So I think it's going to be a lot of fun. Next up, we have.
Actually, yeah.
Go ahead.
No, I totally agree. Like we need to bring fun in our interactions with water. I think that's one of the key opportunities when we design technology for water, that we can actually support and amplify playful interactions with our life in order to really help people to figure out who they are, who they want to become, and how to get there. And I think engaging with water in a playful manner is a key way to get there. And that's why I know you want to introduce the next speaker. That's why I'm really looking forward to that one, because I know they're kind of trying to do that with their really cool work that I really like.
Yeah, and I think that's really good. In terms of fun, I remember when I was up for tenure, on the road to tenure, a lot my colleagues all told me, well, you should not be having fun. Don't have fun, and also don't appear to be having too much fun, because you need to be serious in order to get tenure. So then in response to their advice, I called myself the Frolic Lab. So I said we kind of wrote a paper like first splashes at the Frolic Lab. So we kind of became known as the Frolic Lab, fun and frolic in this lab. And then I started holding for a while I was giving my lectures in the fountain. At Stanford University, there's a fountain out in front of the university, right out in the main entrance. And I decided for almost a whole year, I didn't wear clothes. I just had my bathing suit on, and I would just come in and go to the fountain, and I held all of my lectures in the fountain. And I had all my meetings in the fountain. If somebody wanted to meet with me, I'd schedule it in the fountain. So it was kind of fun. I think I ignored the advice of the people who were saying not to have fun. But
and
anyway,
you got tenure. See, that's what I mean.
Yeah,
life's too short to not have fun.
But I had to publish about 10 times as many papers as the minimum requirement normally would be, because you've got a higher hill to climb when you're having fun, because people don't like to see you having fun. They want you to be serious. But anyway, on that happy note, I think we'll bring Atlas in here, because I'm just loving to see what's going on here. And it'd be super fun to connect with Atlas. It'd be awesome to connect with you in some way in the future. And so take it away.
Thanks a lot for that introduction, Steve. We definitely do like to have fun. Let me share my slides here. Okay. Hi, everyone. Thank you for joining my talk on storytelling in water with aquatic virtual reality. My name is Atlas, and I'm the Chief Content Officer of Ballast Technologies. Using our proprietary virtual reality headsets, we provide memorable experiences to guests while they are submerged in water. The feeling of floating in water, combined with the visuals, combined with the sound, all complement each other to create an impression that is much greater than the sum of its parts, and in many cases can be quite profound. In this talk, I want to share with you how we got to where we are today and what it's like to tell stories in water. There are really two different modes of stories that we tell in water. One is on water slides, one is while snorkeling, and one is while floating. They are all very different, and I think they are all quite interesting. So in August of 2017, my two co-founders and I were invited by one of the world's largest water parks in Europe to move to Germany and develop the first virtual reality on a water slide. Our assignment was to take an existing water slide, just a traditional water slide, a steel tube, no technology on it, and turn that into a virtual reality attraction. That means people would sit at the top of the slide on a raft as they did before, but they would put on a VR headset, get pushed down the slide, and then as they bobbed and weaved down the slide physically, they would have this experience of flying through various fantastic landscapes and seeing various things. This was a really important project for them because water slides are these large, expensive, immobile structures. And once they're built, it's really impossible to change them in any meaningful way. If your park visitors get tired of the basic slide experience to any extent, the only option is really to rip it out and build a new one. So if we were successful, the feeling of a water slide could be changed over and over through the magic of software, which would be really transformative for the industry. This is a very technical group of speakers, so you all know what virtual reality is and how it works, but for the audience, there are really three pillars to making VR work. One is the headset that you wear on your head. And what is special about that headset compared to watching television is that it blocks out everything about the world around you so that you just see the fabricated virtual world and your brain can start to believe that it's there. The second aspect is the tracking system, because when you're in virtual reality, if you move your head to the right, for example, the virtual world has to move to the left by the same amount. And that's what gives you this illusion. That's what creates the magic of being able to poke your head about and move and look and really feel like you're part of a world that's real. The tracking system measures what your body is doing and changes the visuals accordingly. And finally is the content, what you see and experience during your virtual journey. So our challenge was to basically reinvent these core concepts of virtual reality for this water slide, in addition to come up with operational solutions required by a high throughput ride. That meant creating a waterproof headset that could be used by the park. It meant inventing a custom tracking solution, which could deal with the high speeds and chaos and wetness of a water slide. And it meant coming up with content because the content had to be customized for each slide, since the shape of the journey you might take really has to match the physical twists and turns that you take on the slide. And then operational solutions were needed, like the ability to charge headsets while wet and sanitization solutions and so forth. It took us about 5 months to complete this first project and invent all these things, and it turned into a success. the park was thrilled with what we gave them. Ever since then, they've been running about 10,000 paid rides per month at this one location. And for the months that they've been open, that's total to nearly 400,000 paid rides to date at this location. And thanks in large part to the success of this first installation, we had the opportunity to do a half dozen installations all over the world on different water slides. One of the great things about this system is that we let our guests select what experience they're going to have on a water slide just before they go down it. And they could go down it multiple times if they wanted, and to have a different experience every time. From a storytelling perspective, there are all these experiences share some constraints. They all have to be brief, really just the length of the water slide, which is about 30 seconds. And they all have to have non-stop motion involved because your body doesn't stop throughout this experience. So the experience has to reflect that motion. These were all very challenging and interesting constraints from a storytelling perspective. So I'd like to share with you how we solved them for one particular VR slide experience. This is one of my favorites, and it takes place in a fantasy-themed experience in a snowy landscape. When the guest first puts on the VR headset, no one knows how long they are going to sit at the top of the slide. And this is because it is up to the ride operator, for safety reasons, to decide when they will push the rider to begin their descent. This is just a still image, of course, but while they are sitting at the top of the slide in an animated fashion, the initial scene really sets the tone of what they're about to experience. So in this case, they would see falling snow. They would see a dragon ominously flapping its wings over a castle. They would see smoke and fire, and they could look around and really start to sink in and believe where they are, and start to understand that there is danger and a battle happening here, and start to absorb the realities of this world. When the ride starts, the participant moves rapidly through the virtual world and the action starts. In this particular case, the dragon swoops up over the walls and then hides just out of view behind some trees. The guest goes around the trees and discovers there is a charging army of medieval humans. And around the next bend, they find themselves in an epic clash between this charging army and this fire-breathing dragon. The dragon notices your presence and decides to ignite the bridge in front of you, and you escape just in the nick of time through this opening in the rock wall, where you discover deep under the mountain a magical cavern. And eventually you come to rest at this dragon's nest that has 3 eggs and a baby dragon inside of it. And that's how the story concludes, creating this implication that the terrible dragon is actually just protecting her brood and her babies because her nest is nearby. And this is one example in how just 30 seconds and in this constraint of a fast-moving experience, we set the stage, tell the story, and bring it to an end in an efficient manner. So our VR slide system was a great success, but after creating that, we really wanted to come up with different kinds of experiences, stuff that would lead to really deeper immersion and longer experiences that could lead to more intimate connection with the subject matter. So after VR Slide, we immediately hunkered down and created Diver, which is a system that would bring VR to the swimming pool. In Diver, participants put on a waterproof virtual reality headset like before, but this time, instead of sitting on an inner tube, they wear a flotation band, they lie face down in water, and they breathe through a snorkel. The flotation band is tethered to a weight at the bottom of the pool with this elastic band, and this gives the participant the freedom to move their body in a natural way. They can swim if they want to, they can twist, they can turn, they can explore, but really they are held in place physically, so they're not going to crash into anything. They stay in their own little safety bubble. And from a safety perspective, it's worth noting that this is only done in shallow water, and there's always enough slack on the line. They can instantly stand up without any impedance if they decide to end the experience and go above the water. This model of holding people in place in the water as they explore this virtual worlds turned out to be incredibly effective. On land, you have this strong sense of whether you're moving or not. For example, if I put you in a chair and gave you a virtual reality headset, the illusion wouldn't be complete. If the VR was moving, you would know that you weren't moving, unless I went to a lot of effort to pick up your chair, shake it, move it around, create accelerative forces for you. Your brain wouldn't be fooled. But in water, that is very different. If you think about if you're caught in a current in the ocean, for example, if you close your eyes, you really can't tell if you're being dragged rapidly to the east or rapidly to the left. The nature of water makes it so that the participant's mind really accepts whatever virtual perceived motion it is presented with. So with that said, here is an example of one of the virtual reality experiences we offer for the diver system. Because of the relaxed feeling and pace of floating in water, diver experiences really lend themselves to slowing down and taking in the sights. So in this particular experience, there's a lot of oceanic animal life that swims around you and you get to explore it. There are a lot of beautiful coral reefs, there are caves, there are sun shafts, there's a lot of plankton that dances in the light as it catches the light. And for this story, this particular experience, the story we tell is one of a baby whale that is caught in fishing lines surrounded by sharks that are circling around it at the beginning of the experience. That sets up the tension. The baby whale escapes from the lines and the sharks, and you get to follow it for the next 5 minutes as it searches for its family. And you go past shipwrecks and coral reefs, and you go through kelp forests. And at the end of the experience, the sharks catch up with the baby whale, and there's a rescue where the whale's family comes in at the last moment and chases the sharks away, and the baby whale is reunited with her family. Even though our diver system takes place in the water physically, it really works with any subject matter where either flying or floating or falling makes sense. So for example, in addition to our water-based experiences, we let people explore the International Space Station, and that works just as well. We also have an experience where people can go skydiving and flying in a wingsuit and look around and see their squad flying with them, and that also works quite well. In 2020, we were invited to the Sundance Film Festival, where we presented a 9-minute experience in a pool there. We ran 3 stations in the pool of Sundance headquarters. We partnered with a filmmaker, Pierre Fouquet, who made this particular film. But it was really interesting to see the traditional film setting and how well aquatic virtual reality worked in that setting. Since inventing Diver or creating Diver, it has launched in dozens of locations. Here are some of the most significant ones. And after our successful Diver launch, we teamed up with a talented aquatic attractions company called Subsea Systems, and we created Diver Plus. And Diver Plus is a haptic feedback unit that takes the form of a stationary vehicle that gets mounted to the side of the pool. This is an add-on to Diver. You can see how the participant is wearing our standard Diver system on his head, but now he is also holding this haptic feedback unit. The unit can propel water towards the participant at various speeds. These changes in speed are timed with the experience, and this can create the feeling of acceleration and deceleration as the story requires it. It can also blow air bubbles out of that front opening from compressed air canisters at key moments, and having the air blow past your body creates sensations such as brushing past seaweed or brushing through schools of fish. Or if you're flying, it might give you the impression of having a near miss with some rocks because you have the slight sensation on your body. And it can also shake the handles, which gives you this impression that you're holding this very powerful vehicle that's accelerating. Within the experiences themselves, we show virtual arms and hands of the participant holding some kind of virtual version of this vehicle. So, for example, we'll show you holding a high-speed underwater scooter if you're exploring the ocean, or holding some kind of jetpack vehicle if you're exploring outer space, or maybe holding onto a hang glider if you're flying over landscapes. And because of the large amount of water that we can make rush past you from this unit, it can achieve some of the highest perceived virtual motion of any of our systems, which can give you this really thrilling feeling of having traveled literally miles within a 5-minute experience. We've also experimented with virtual reality in float tanks. This was a very interesting experiment for us. We wanted to see what it was like to create even slower, more long-form meditative experiences. So we created a 17-minute experience called Breathe. In this experience, the participant is invited to breathe in time with various jellyfish that they encounter. These are friendly jellyfish. They're very ethereal. They're glowing. There's all these sparkling lights going down their inner structure. And everything in the experience pulsates brighter and darker and open and closed with the undulating rhythm of a slow human breath. Even the water around the participant swirls and gets brighter and darker, as if the water is filled with millions of pieces of bioluminescent life that are all breathing in unison. As the experience progresses, participants get to encounter different species of jellyfish. This one has these long, beautiful skirts, and the head of the jellyfish expands during the human in-breath. And then as the participant exhales, that glowing light travels through the skirts, almost as if the jellyfish is squeezing out the breath. And it really enhances this feeling that you're breathing with this glowing, beautiful, ethereal animal. One thing you really can't express in a presentation is just how powerful many of these experiences are when you're really doing them in water and in the actual system. But if you're passing through New York and would like to try this experience, Next Level Floats in Brooklyn is providing Breathe as an option for their floats. Thank you for joining me on this recap of our journey, exploring this strange and exciting new storytelling medium of aquatic virtual reality, from fast-paced VR slides on one end of the spectrum all the way to these slow meditative floats way on the other end of the spectrum. I hope this talk has given a glimpse of how magical and transporting storytelling in water can really be. It's been a really thrilling journey over the past 4.5 years, discovering all of this medium has to offer, and I'm excited to see where it takes us next. If you'd like to learn more about the work we do at Ballast, including some videos of our installations in action, you can visit us at ballastvr.com, or I can be reached at atlas@ballastvr.com. Thank you very much.
Thank you. That was absolutely wonderful. That was really, really good. Very, very, very nice to see, and we'll definitely continue to be in touch through the website and everything. And Atlas, we should get you up here to Ontario because we're doing a lot of really exciting things with water here, and it would be super great to talk about what we can do in the Canadian sector, as well as in, I've got a place in Palo Alto and a place in Toronto as well, so I'm back and forth, so maybe we'll see what happens in the nexus between California and Canada. Ontario.
Great, sounds good.
Thank you, everybody, for participating in the 23rd annual WaterHCI conference. And we've done many fun things over the last 23 years in this sort of vastly growing field. And I hope that we continue. You know, maybe the conference 2022 hopefully will be held. I don't know. Maybe who knows what'll happen. It's traditionally we've always held it here in Toronto because it's just been kind of a small thing among a few friends and everything. But as it grows, maybe we'll talk about moving it to California, or moving it to a water slide, or moving it to a water park. I'd love to host Deconference 2022 in a water park with VR water slides and all this kind of fun stuff too. Who knows? Anyway, I'm open to ideas. Let's keep the discussion going and have some fun and frolic. And it's been fun. You know, everybody told me I should be a ladder climber and I should do the right thing and be serious and do work and try and advance my career and everything. And I sort of instead just decided to have lots of fun. And I think I don't regret any minute of it. So stay in touch and let's keep it going. So thank you. And we'll post all kinds of stuff. We had a really great swim today. We'll post some materials. We'll post the talks on the proceedings. So we'll put the conference proceedings on the website, and we'll also put the videos up. If any of you have slides you want to send me, or if you've got self-recorded videos, if your recording turned out better than we recorded all the talks here over the web, but there's a bit of delay. So if any of you recorded the talks yourself or have slides, send us that material so we can put that together with the proceedings. And it's been fantastic. Thank you.
Thank you. Good to go. Sign off.
Yeah. And thank you for all the people that helped, Ryan, Caden, and Dr. Draw, and Perry, and everybody else at Swim Up, our 560 members of Swim Up, and thank you to the McLuhan program and all the people in the Equivalence Working Group, and thank you to everybody at U of T who's helped over the last 23 years, and all the people who've been involved in this project. Thanks so much for all your contributions and help. We really appreciate it. It's wonderful to have all these smart people joining us, all these smart and fun people joining us. Good.
Okay.
Now it'll keep streaming. There's a delay, I guess, too, right?